Alright, this is going to be covering 3.3, Analyzing Graphs of Quadratic Functions, and this is part 1. There are two ways of presenting quadratic functions, and we have talked about the one that where we have ax plus b, or ax squared plus bx plus c, and that's the one that most people are aware of, okay? We also have what's called the vertex format, okay, and this is the vertex format. And specifically, we have the h and we have the k, all right, the h and the k on this. The h is our x value for the vertex. All right, and this is actually something that's pretty easy to find. We've already talked about this in terms of the other types of, or the other format, and we'll talk some more about that in our upcoming, in the rest of this. But I want to show that this is my my x value, and we ignore the negative right here. I want to make sure we're real clear on that. We ignore the negative right there, because this is our h and this is our h. And then our k, that is our our x or our y value for our vertex. So just a couple reminders. The graph of a quadratic is a parabola. It is not a parabola. It doesn't have any Ebola related to it. Okay, it's a parabola. The vertical stretch is created from the a. So the larger the a in terms of absolute value, the steeper the curve goes up. All right, so if it's a very large number, it's going to go up much quicker than it would if it were a different number. All right. Reminder too that if we have a greater than 0, it opens up. Sometimes you think of it as in terms of being a smile, and that means we're going to have a minimum, right? If it's smiling, there is a point that's the lowest that it goes, and that's it. That's the minimum. If you have a is less than 0, you've got negative values. The parabola opens down or frowns, and then the k is the maximum of the function, all right? So here, we've got a couple of things to think about. We have our axis of symmetry, which is our h, right? No big surprise there, right? We already know that it's going to be our x value of our vertex is going to be our axis of symmetry. In the format of x minus h squared, if h is positive, right, this number is a positive number, the parabola shifts to the right. All right. If h is a negative value, it moves to the left. All right. And it's important to note that if you have a value, right, some number here that's negative, and you're subtracting it, it's going to be presented as x plus h. And you just need to keep in mind that those two, that's a double negative there. And so we ignore that first negative. The second negative tells us that it's going to move to the left. The k tells us to move it up or down. All right, so a couple things we should look at. We want to think about, we've got our axis of symmetry, and we know what our x value for that is going to be. That's our h, right? We've got a couple of different variables going on here. So there's our h, here's our k, and our k, when we have, this is a -2, so it's going to move down below the x-axis, right? It's going to be down below the x-axis on this particular shape. Now, because a is positive and our k is negative, we are going to have two real solutions. If we have a negative a, so our a is negative and our k is positive, then we're again going to have two real solutions. All right. If we have the same sign, for a and k, no real solutions. And if you think about it, there's only one other option, and that would be, regardless of whether it's a plus or an a minus, right? If it's a negative or a positive value, if our k equals 0, we have one real solution. Okay, and I should probably just erase that little paren right there. Regardless of whether it's the a stops mattering when you have the k equal to 0. Okay, as long as the a isn't 0. If your k is equal to 0, you have one solution because your parabola is just touching, right? It's just touching your x-axis. All right, so hopefully this is a little helpful. Couple things to keep in mind. Remember, we have this double negative going on. So we ignore that first negative. We move it to the left because this is going to be a negative value. And then this negative here tells us to move down. Here we have positive 2, right, which is our a, and we have a positive 3. This is going to tell us our x value is a 1. Remember, we ignore that first negative. Right, so our x value is a 1. And this is going to move us to the right 1 unit. All right, and then we have a plus 3. So that means our vertex falls at plus 3. Now, that's not a big deal, except that it tells us there's no real solutions. Here, if I have a negative, I have my negative 2. This is exactly the same setup, except that the 2 is negative here. And it flips the whole thing over so that instead of it opening up, it's opening down. Here's our vertex, and so now we're back to having two solutions. Okay? So when we have a case of ax squared plus bx plus c, we can always solve for the h value by using our negative b over 2a. And then we're going to substitute that h, right, which is what we've just found, back into the equation. So we're going to use I'm going to use a formula here. I'm going to use this formula. I've got x squared plus 2x plus 1, and we're going to sort out what our h and our k is. So first of all, I'm going to go ahead and put this into red, because I'm going to have my minus b over 2a, which is going to equal, well, my b here is 2, so I'm going to have a negative 2 over 2 times 1. So I'm not going to do the times 1. I'm just going to leave it like that. It seems silly to multiply by 1 for no good reason. All right, so in this case, I have a negative 1. All right, now I'm going to take this f of negative 1, and I'm going to plug it back into this equation. So I have a negative 1 quantity squared plus I have 2 times negative 1 plus 1. All right, so this is our h. I want to just quick remind people, we've got our h. Now I'm going to go ahead and just do that math right there. That's going to give me a 1 minus 2 plus 1. That's going to give me a 0. So my ordered pair for my vertex, my h and my k, right, my ordered pair is going to be negative 1, 0. And because this is a 0, I'm going to have exactly one solution. Okay, I'm going to have one point where it touches the intercept. I'm actually going to stop here and pick up in our next video.